Find polynomial roots, pre-calculus, pre-college math. For this video, I'm actually going to skip number 1. We may come back to it. I'm also going to skip number 2. We may come back to it in class. And I'm actually going to start with number 3. So I think this is one of the harder ones, and I'm only going to do one example in this video. I want it to be one of the harder examples. So the past couple of days, we did a couple of days of long division to test to see if a root or a factor was indeed a root or a factor, and we knew that by getting a remainder of 0. And then we did a couple of days of synthetic division. Same thing, we were given a potential root, and we did synthetic division to see if it matched. And then I believe the previous lecture was we were given a root. It was definitely a root, and synthetic division told us we had a remainder of 0. And what we were left with was then a quadratic that we were able to complete the square and find the 2 remaining roots. So we were given one of the 3 and found the other 2 with synthetic division and completing the square. Today we're just doing the same thing, except you're not going to be given that 1. So the fact that this is x to the cubed as our highest exponent means we are looking for 3 roots. And as I said, the previous video, you were given 1, and you divided it out and completed the square. So all we're doing is we have to first find that 1. So we have to find one of our roots, and we're going to use our calculator to do that. We're going to find one of the roots with the calculator, use synthetic division to divide it out, and then with the remaining quadratic complete the square, just like we did yesterday. So all we're adding to what we did in the previous video was we have to first find that 1 root. So the way we start this off is our calculator, we type this into the y equals, and I already have this up here, 6x cubed minus 14x squared minus 32x plus 12. And zoom 6 is always a good way to start, because that gets you on your standard view. So zoom 6 will give us this polynomial right here. Now, you don't need to draw this picture, and I'll probably delete it in a moment, but I just want to point out where these roots are. Remember the roots. Roots are where it crosses the x-axis. That's right here. So we have 1 here, we have 1 here, and we have 1 here. We need to figure out what these are. Now, there's a good chance that, as we know from yesterday, that 2 of these roots could be irrational. But at least one of them is rational. At least one of them is a fraction or a whole number or something. And that's the one that I need to find, because that's the one I could use with synthetic division and divide out and stuff like that. So let me get rid of this picture here. But show you how to do this on your calculator. So what you're going to do is on your calculator screen, and we did a little bit of this in Algebra 2 in the quadratic word problems, but I need to do this whole left-bound, right-bound thing to find out what these numbers are. And when one of them comes out to be a normal-looking number, I'm going to use it. So I'm going to start left to right. So the way we do that is we do second calc, and we do 0, because a root has a y value of 0. So the word 0 in your calculator, same thing as root, solution. So choose choice 2. When you do that, you may or may not see the flashing symbol. But it tells you where it is. We're at the coordinate 0, 12. 0, 12 is probably like up here. So if I hit the left arrow button, I will, oh, there it goes. You want to find that flashing guy. And remember, this tells you where it is. So I'm at negative 1.7, negative 3.6, so I'm right here. So if you ever get lost or can't find it, you use this as a guide to kind of see where it is. You want to find it. Now, first thing you need to do is be to the left of it. So this is the first root I'm going to test right here. And I need to be to the left of it. And to the left of it is below it in this case. Because if I go to the right, I get above it. And you can see my little guy up here. So I want to be to the left of it, which is below it. Hit enter. Then I want to move to the right of it, which I think just hitting the right button once will move me to the right of it. Now I'm there. So there's my right. And then I hit enter a third time. And it guesses that this root is negative 1.645751. If you get a decimal that's more than a tenths, a hundredths like this is an irrational number. This is not useful to me right now. You can make a note of it and use it to check your work later. but it's not going to be helpful for synthetic division because I can't divide out an irrational number like this. So this is not one of my roots that I can use right now. And the fact that it's irrational means that one of these is also irrational because they come in pairs. But one of them, I promise, one of them is a normal number. It may not be a whole number, it might be a half or 2/3, but it's a normal number. So I got to find that. So I got to test these now. So let me go back to second calc, 0. But this time I want to try for this root here. Now, if you don't like this picture, you can adjust this picture to give you a better looking feature. And sometimes that's helpful that I can kind of cut off the ends here. This is some extra x-axis I don't need. Like my x-axis really only needs to go from like, I don't know, -4 to, or let's say -5 to 5. So I can start there. Let me go to window, and my x minimum, let's make it -5. My x maximum +5. Now you don't have to do this, but it just helps kind of give you a better picture sometimes. So that's much better. Now I could zoom out for the y-axis if I wanted to see this whole thing. What it really looks like is if this is your x and y-axis, the graph is doing something like this. But right now we're only seeing like in here. You could certainly zoom out to see the rest of it, but really all I'm interested in is the root part, which is in here. But you could try just hitting the zoom in button, or you could adjust the x-axis to cut off the extra on the sides. So you could make a nicer window if you want. So let me go back to second calc 0. All right, now it's kind of hard to see where my bug guy is, but I know it's at 0, 12. X 0, 12 is up here. I want to go down here. So if I hit the right button, it starts to appear. So here he is. All right, so this is about where my root is, but I need to be to the left of it. So I hit the left button. Now in this case, left is above it. The other case, left was below it. Let me just explain that real quick. That if you have a curve, for this point right here, below it is to the left of it, and above it is to the right of it. Left, right, left, and right. But if I have this curve over here where it's kind of coming down, this, because the graph goes this way, this is to the left of it, and this is to the right of it. So sometimes you'll hear me say above it and below it, but always remember left and right. And if you're not sure if left is above or below, well, just hit the left button and see which direction it's going. As I'm hitting the left button, it's going up. So that means that left is up. And as I hit the right button, it's going down. So that means that right is down. But that's going to be different for each one of these. So don't always assume left is below or anything like that. It changes depending on how the graph is curved. So right now, left is above. As I hit left, it goes up. So I want to be to the left of it. This is a good spot to the left of it. Hit enter. And then I need to move to the right of it. And by it, I'm talking the x-axis. So left of the x-axis, right of the x-axis, enter, enter. And it tells me this point right here. 0.33333333, which you may think is irrational, but it's actually not. A repeating number like that actually is a rational number. 0.3 repeating is equivalent to 1/3. So if you see 0.3 repeating, 1/3 is what you're dealing with. And that's actually what we're going to use for this problem. You could test this other one to see if this one's better, but it's not going to be. It's going to be irrational, just like this one was irrational. A lot of times you're going to get numbers like 2, 2.5, 1.4, stuff like that. And you could just type it in, math, enter, enter, and it will convert for you. But 0.33333, you should probably know that's 1/3. And that's what we're going to use. So we used our calculator to find our first root, and that is 1/3. So our first root is x equals 1/3. And now I'm done with the calculator. Now I'm going to do what we did yesterday. I'm going to take that root of 1/3, and I'm going to apply synthetic division. Remember, you always want to check for any gaps in the coefficients. I have a 3, a 2, a 1, none, so I'm good to go. 6, -14, -32, 12, and let's see, bring down the 6. 6 times 1/3. Remember, multiplying by 1/3 is the same thing as dividing by 3. So you could just think of this as divided by 3. But 6 times 1/3 is 2, because 6 divided by 3 is 2. This will combine to be -12. Times 1/3, or divided by 3, is -4. This will combine to be negative 36 divided by 3, or times the third, same thing, is negative 12. And this better be a 0. Must equal 0, because if you're finding a root, that means you have a remainder of 0. So that's kind of a confirmation that so far you're correct. You know, if you're given 1 and you tested, that's one thing, but we found this to be a 0, so that has to work out. What you're left with is a confirmation that 1/3 is a root, but then you're left with a 6x squared minus 12x minus 36 as a quadratic. And the way we're going to solve this now is set it equal to 0 and complete the square to find the remaining 2 roots. And from what I did over here, I actually know they are irrational, so I'm expecting something like something plus or minus some radical, so on. Video is running a little late, so I'll speed this up a little bit. But divide by 6, we get x squared minus 2x minus 6 equals 0. X squared minus 2x equals 6. X squared minus 2x plus 1 equals 6 plus 1. X minus 1 squared equals, that's supposed to be 1, 6 plus 1 equals 7. Square root of both sides, you get x minus 1 equals plus or minus rad 7. And finally, x equals 1 plus or minus rad 7. I did that fast, but we've talked a lot about completing the square already. So your 3 roots are x equals 1/3 we got from the calculator, and 1 plus or minus rad 7. Okay, practice this more the next day. See ya.